Hello everyone and welcome back. It's been a while since my last video, but I have not been sitting still. Like many of you, I have not been able to go to work much last year due to COVID, and with the time available I decided to do what I've been dreaming of for a long time, and it is to build a workshop in our backyard. And that's where I'm sitting right now. You can't see much of it for a moment, but in this series of videos that I'm about to do, you will probably also see more of the other side of the workshop, as I will be recording from there too. But the topic for today is to give an introduction into this series of videos that will be all about laser cutting. Now, I've been thinking about attaching a laser to my CNC for a long time, but if I would have done it earlier, it would have been just out of interest and not really because I had a use case of it. I was just really interested in how laser cutting works and what the possibilities are. So I decided to wait until I have a use case for it, and now I do. What I want to do is something that has to do with the making of PCBs. For those of you who wouldn't know, but I think most of you will, PCBs are printed circuit boards, and here you see two examples. On the left hand side it's a homemade PCB that I recently made and that controls all the electricity and also all the lights in my workshop. And on the right hand side you see a picture of an Arduino Uno. Of course, the homemade PCB looks less professional than the Arduino, but the main feature that it lacks is the green stuff that is covering the Arduino, which is the solder mask. I didn't use solder mask on my own PCB because I have no method for the moment to remove the solder mask from those places that needs to be soldered afterwards. And that's what this series of videos is going to be all about. The solder mask is there to protect the copper of the PCB from oxidizing, but also to greatly facilitate the soldering process when you actually solder the components to the PCB. When you apply solder mask to a PCB, one of the things that you need to take care of is to avoid solder mask from covering the solder pads. The solder pads are the locations on the PCB where the soldering has to be done. This can be done in two ways, either by avoiding the solder mask from attaching to the solder pads. Another way is to cover the entire PCB with solder mask, let it cure, and after curing, remove the solder mask with a very small router bit. Now, neither of both methods are very easy. I will not go into detail why, but there are a few problems with both methods. So what I want to try is to still cover the entire PCB with solder mask, but instead of removing the solder mask from the solder pads with a router bit, to remove it with a laser. And that's where my use case comes from to finally decide to attach a laser to my CNC. The next question is, which laser am I going to use? There are of course many standalone lasers available, ranging in price from really cheap to really expensive. But if you buy a standalone laser cutter, you pay for both the laser but also for the mechanics. And since I already have the mechanics in the form of an Avid CNC router, it made sense to me that I would spend the money only on a good quality laser head. So I started to look around on the internet, and I was looking for companies that make laser attachments for existing CNC machines. So I came across this company, which you can read here, which is called Op Lasers, and they make laser attachments for popular CNC machines. They also have generic versions, but they sell attachments for specific popular CNC machines, such as, I have a look on the website, I see here Chez Poco. I never quite know how to pronounce that brand, but you know what I mean. X-Carve, and also Avid CNC, and a few other Stepcraft and a few others that I see mentioned on their website. So I contacted these people, and I was quickly replied by Matthäus, who is the CEO of this company, and I explained him what I wanted to do with it, and he was quite interested in this specific use for their laser product. So they agreed to send me a unit, and in all honesty they send it for free, and I would do some testing on it for this specific problem relating to PCB making. So that's going to be the focus point of the series of videos that is coming up. It's not going to be a review in any way. The aim of this series of videos is to explore the use of a laser in relation to PCB making. I do want to say something, however, about quality requirements regarding to lasers. As I mentioned before, this unit was sent to me for free, but in fact I was planning to buy this unit. It was not until I was talking with Matthäus of Opt Lasers where it became clear that in all honesty they said, we have not yet tested this specific use case. And then the idea came up to propose to him that I would do it, and along the way there would of course be some exposure of their product on the internet, which is win-win for both of us. But if it would not have been for this discussion, or if he would have said, yeah, we tried it and we know it works perfectly, then I would have bought this product. There is of course the option to buy much cheaper lasers on the internet, lasers with a much higher power than this specific one. So why don't I do that? Well, a word about power. This specific laser has got a 6 watt power rating. Now what does that mean? You can look at power rating in different ways. One of the ways would be to put a measurement instrument on the input side of this laser and just measure how many watts of power it needs. But that doesn't tell you anything about how much laser energy that is produced by the actual laser inside. There's quite a bit of energy that is lost in heat and in letting the fan blow and so on. So only a fraction of the energy that goes in is transformed into actual laser energy. A lot of sellers out there try to trick you into saying that they sell you a 20, 30, 40 watt laser, but what they talk about is input power. What you need to know is how much output power there is. And in many cases, if you have, for example, a 20 watt laser, the cheaper lasers that you can buy, they will sell you that for maybe 100 euros. But if you look carefully, then the output of the laser will be maybe 4 watts. So that's one thing. The second thing to consider is that once you know how many watts of output power your laser has, then the next thing is how well is all that power focused onto your project, because there is no use in spitting out 10 watts of laser power if it's not well focused in a point that is as small as you can. And small focal points can only be made with good optics, and good optics don't come cheap. Compare two DSLR lenses, both of them with a focal distance of whatever, 250 millimeters. One can be 500 euros and the other can be 15,000 euros. The difference is in the quality of the optics. And that's where companies can save a lot of money by using cheap optics that finally give you bad focus and hence a bad cutting result. And that is why this specific laser, even though it's only 6 watts, it's 6 watts of output power, which is focused by good and expensive optics in a really small point. And that is the reason why I would have bought this unit if it hadn't been for the talk I had with Matthäus, where he proposed, listen, I will send it to you, work with it, and please do us a favor and give us some exposure on social media. So It's only fair to have this little discussion about things to think about, quality relating, and how it comes that lasers like this are fairly expensive as compared to higher rated lasers with more power that come at maybe 1/10 of the price of this one. Now, a few more details about this specific laser. It is, and I have to cheat, a PLH 3D XT50 laser. It's one of the new models. They just came out with an XT50 and also an XT10 model. The 50 refers to the beam spot size of 50 micrometers. The XT10 model has an even smaller beam size of only 10 micrometers. There's a little bit of a trade-off between beam spot size and cutting time. If you only need to trace lines, then a smaller beam spot is better because of its higher energy density. If you're going to burn away surfaces, like I need to do with the solder mask, then it might be more interesting to use a slightly bigger beam spot, because that's going to require less passes, of course. However, with a lower energy density. It's a relatively short wavelength laser, a blue laser with a wavelength of 450 nanometers, which is nice because shorter wavelengths tend to have better absorption characteristics than longer wavelengths, such as, for example, infrared lasers. The laser also comes with a control box, some protective equipment, the necessary wires, and a power brick. So the next video will be about the installation on my CNC router, as well as my first cutting results, and from there I will work my way up to the actual goal, and that is to produce PCBs. So I'm very excited about this new project. I can't wait to install it, and I hope to see you soon. Bye bye.